All right, thank you everybody for joining us today. We're going to be covering creating synthetic sensors through equations and ratings tables in Contrail. This is one of our standard Contrail training series where we will be going through and discussing how to create synthetic sensors, what are the different types of sensors, how can we leverage those things to get even more information out of some of our sensors that are out in the field, maybe bringing in information that we want to glean some and create additional sensors and data through our real sensors out in the field. With that, I'm going to go ahead and get started here and cover some basic nomenclature here for us. And so first up, we're going to talk about the different sensor types. We have really three different sensor types within Contrail that we're going to be covering today. And I'm going to actually show that on our systems, and we'll walk through the different types. With one of the last types actually has an additional component to it. So I'm going to add a sensor type here within Contrail just so we can walk through the different types of sensors. Okay, so like I said, we have three different sensor types. We have a real sensor, a synthetic sensor, and equation-based sensor. So I'm going to walk through those really quickly and touch on the equation time series sensor at the very end. So real sensors are sensors that are directly measured out in the field. So these are time series or information for let me see if I can. These are real sensors are sensors like battery, stage sensors, anything that is directly measured out in the field, right? So they are sensors that are taking a measurement and sending that data point back to Contrail, and we are capturing that data point and storing it. So it is a one-to-one relationship. So something is measured directly out in the field, and we are directly recording it in Contrail. So battery is a great example, right? We're getting some sort of voltage out in the field. There's some sort of device recording that battery voltage, and we're sending it back to Contrail and storing that. So that is what we call a real sensor, right? Synthetic sensors are sensors that are derived off of real sensors. So those are really, there's kind of two main types of those, but we're not doing any sort of equation off of them. So we're not having some sort of calculation that needs to be derived. It's some sort of either calibration or lookup that we're going to be looking at that. So a synthetic equation or a synthetic sensor is often considered for rain increment. So a lot of times, especially alert and alert 2 systems, they transmit an accumulated value. So this is the total rainfall that has been received since a certain date or since there's been some sort of rollover. And we need to synthetically derive what is my incremental value off of that. Another example is that we're going to be covering today is deriving flow rates. So a lot of times there is a stage sensor out in the field that is measuring the water above a particular water level recording device, such as a bubbler or a PT or even a radar sensor. We are recording that real sensor out in the field, but we want to convert that to a flow rate, right? And so we have what we call a flow rate table, where it will look up the value of the real measurement out in the field, which is the water level, and it will convert it into flow rate. So those are the kind of the two main types of synthetic sensors, and by far the most common types that you will see in systems defined. The last piece is equation-based sensors. So these are synthetically derived sensors where they are not real sensors. There's no 24-hour average sensor out in the field that's recording something. We want to create that ourselves. So these are more or less a free-form area in the software where we can define certain formulas and variables within the software. And when a new data point comes in for any of those other sensors, real sensors that are out in the field, we will compute an equation, right? We will pass through those data points into our equation. Whatever value comes out of that equation, that's what gets inserted into the database and stored and visualized and alarmed off of. A great example of that is dew point. Dew point is a calculated equation-based sensor, right? So it's a combination of temperature and relative humidity. Evapotranspiration is another good example, right? These are all sensors that have some sort of equation that needs to be applied to maybe a couple different either real or synthetic sensors that are defined within Contrail. This is also actually how we do our unit conversion. So if you want to have multiple unit types within Contrail, you're actually just going to have multiple equations, and we can convert Fahrenheit to Celsius or anything else like that through these equations. So we can see that in our when we create a sensor, we have 3 different types defined here. So when we're maybe setting up our stage sensor, we're going to select real because whatever's getting recorded out in the field, besides calibration, we're not going to really do anything to that sensor, right? It's not going to go through an equation to record that. It's just going to be inserted. Synthetic sensors and equation sensors, we're going to want to do something outside of that data point coming in. It's being derived off of a real sensor. The last type, and it's really a subcategory of the equation sensor type, what we call time series sensor types or time series equation types. Time series sensors are if we want to apply an equation on set intervals. So let's just say we want to have a 24-hour average that is going to be calculated every hour, right? We want to look at, hey, what was the average flow over the last 24 hours for this particular sensor? And we want it to be updated every hour. But maybe our sensor out in the field doesn't actually report every hour, right? And so what we need to do is have a equation sensor that is going to trigger every hour, regardless of whether it has data, and calculate and create that equation over a particular time series. So that is those are the different types of sensors that we can use in Contrail. And every single sensor is going to fall into one of those 3 or 4 categories, depending on what we're doing. So we're going to walk through and really focus on the synthetic equation and time series sensors today. And so first we're going to start off with synthetic sensors. Before we jump into that, I just want to highlight in the Contrail administration help document, really detailed sections are laid out in here. If you just search synthetic, in chapter 3, there's administration sensors, really digs into all of these different types, right? So we have our equation sensor and time series equation sensors. So if you guys want to dig in to see all of the different equations that are built in that we want to, or formulas that we want to leverage and use, go ahead and check out our help documentation in chapter 3. It really digs into just about everything I'm going to cover today, and even more detailed, and walks through step by step on how to create a lot of these things. So I would recommend go ahead and bookmark and pull that up. If after the fact you do have a question, go ahead and take a look at this. It's a really great view within the help documentation for everything I'm going to cover today. All right, so first up, I'm going to actually go through and create a couple synthetic sensors. So these are rain increments and flow rate sensors, right? So we're going to be deriving information synthetically off of something that's recorded out in the field, and we're going to use that in just a couple basic lookup conversions that we have. So first thing that I'm going to cover is probably the most common sensor within Contrail, one of two, and it is the rain increment sensor. This sensor is used if you want to look at the total rainfall over the last 24 hours, or look at rainfall in real time. This shows the individual tips that we want to look at, as opposed to precipitation accumulation is a total rainfall since a set time period, since it has been last been reset. So with that, we're going to go ahead and create a rain increment pretty quickly here. So first we're going to define the site and system, because I'm already on the particular site I want to create it to. The antelope site here, it's already selected. But under sensor type, we're going to search and pull up rain increment, give it a second here to load. And we can see, because we have this rain increment sensor type already defined as a sensor type within the system, a lot of the information that you see on my screen has already been pre-populated because we've already defined that sensor type. So we can see synthetic has been selected. The units, precision, and interval, expected interval, is defined below that. We have a date time. What is the date time of the sensor that it's being received to? And then we can see we have our conversion here. So for rain increment is a very specific type of sensor. For those that run alert and alert 2, you probably already have your exact conversion type. You already know which one you're going to select based on what's defined out in the field. But the most common type is this increment only measurement. But if you do have maybe some legacy alert hardware, you may or may not be using the ink up and ink up down conversion type. So we're going to go ahead and select this increment only measurement. We can see our conversion to inches is applied there. I'm going to give it a sensor ID of test, so I know to delete this later. We're going to click save. Now the next screen that pops up is we need to attach it, because we're synthetically deriving it off of a real sensor that's actually recording and pushing data. We need to select that sensor. So I'm going to pull up my antelope site and select my precipitation accumulation sensor. And we have a couple of options down at the bottom to use the raw values, which is what we want to use. And then if we want to use all collected data, or only the data that has been validated by Contrail's built-in validation. I'm going to leave both of those defaults as is for right now. I'm going to click save. And now we have our new rain increment sensor. So this is being synthetically derived off of our precipitation accumulation sensor. So as reports come in, you'll continue to see 0-inch reports, as well as tips when it does actually start to rain out here in Colorado, which it hasn't in a while. If we scroll down to calibration down at the bottom, we can see we have our conversion is set to this increment only measurement, and we can see the exact sensor ID that it's being derived off of. Right, so if we click this, we can jump to that precipitation accumulation sensor that we're being derived. The data is being derived off of. A note about synthetic equations, as well as synthetic sensors, as well as equation sensors, is if you ever want to revalidate or repopulate data, have it kind of reset its brains, you're always going to want to do it at the parent site. Okay, you're never going to want to do it on the synthetic sensor. You're going to want to do it on the real sensor that it's being derived off of. The way the software works is when this gets revalidated, this sensor, it will actually push that data through to the sub or the child sensors that are attached to this one. So just keep that in mind as we go about this. I won't be doing a ton of revalidation, but just keep that in mind. If you do it, on one of your synthetic sensors, you're going to need to do it at the parent set. Okay, so that's rain increment sensors. Another very common sensor type that's in the synthetic category is flow rate. So this is converting a water level reading to the amount of water flowing through a channel, right? So what is my flow rate? It has both a, let's say, typically a volume per time that we're going to be looking at. So in this case, cubic feet per second is this flow rate defined within this. So we're going to want to do the same thing. We're going to click the add button here. We already have the site and system that we're going to attach it to, but under the sensor type, I'm going to select flow rate. And I'll show in just 1 second, if this hasn't been defined, what you're going to want to do. You're going to want to make sure synthetic is set up here, is clicked here. Again, we want CFS. And then under conversion here, this is important, we're going to be looking at these rating table lookups, right? So it's going to be one of these 3 options. So we have a couple different options for looking at this. We have a basic 1-to-1 rating table lookup. This is ideal if you're looking at maybe status messages where you're expecting maybe 5 or 6 different types of error messages that can be received. It's a 1-to-1 lookup, right? If we get a 0 reading, we're going to convert that to no or off or something like that, right? The rate table linlog and table log, these are 2 different types of rating table lookups where they will actually use linear logarithmic and logarithmic interpolation. Depending on the usage case, you guys probably, when the ratings tables were generated, you're going to want a specific type of interpolation. So I won't really be covering that, but do know that there are 2 different types. I think the most common type is this linlog here. So this will, if we get a reading that is maybe in between 2 rating table lookup points, we're going to interpolate that data point between those 2 points and actually get a flow value for that. And this makes it a lot easier because we don't have to have our rating table lookup cover every single type of point that we can expect, data point that we can expect to come into the system. So I'm going to select this table linlog here. I'm going to click save. I'm going to give it a sensor ID before I click save. Now on this next page, again, we're going to want to select the site and sensor that we're going to synthetically derive the data off of. We're going to be picking off of this stage sensor, this water level sensor. Click save, and we're going to get an error message up at the top here, along with the successful message that we created this synthetic setting. But we also need to define the ratings table. There has not been one defined. We look down below, we can see the conversion type is rating table lookup, and we can see the stage. So we do have a couple, or there's one way to add in that ratings table. Under the drop down here, we can see there's a ratings section. You can see there's no ratings defined. We're gonna go ahead and click import here. And I actually already have a ratings table defined, but we'll see that in, I'll go ahead and show that. If we look at it, it's just a site ID, sensor ID. It's the input and the output. So when it's the water level is 0.06, it's going to be 0 CFS, all the way up to 11 feet here. So I'm going to go ahead and drop that table lookup. It was comma, so we're going to have that as comma. If you have it as tab, you would just select the tab option here. I'm going to go ahead and click upload. On the next screen, we'll see that there is an input field and an output field, and this is just to verify that you have the columns named correctly for it to look up. So you can see we have 0.06, and the output CFS will be 0 here. We'll click save, and we'll see that table actually loaded into the software. So we can see We'll go up to 1 CFS once we get above about 4 inches here of water level, and that goes all the way up to 4,000 CFS for this particular site. We have a couple things. So Contrail, you can always export other ratings tables if you want to maybe edit or tweak it, or if you just want to delete it altogether. So now if we go back to our sensor, we can see our error message is gone. And as new data points come in for this stage reading at this antelope site sensor, new data points will come in. It will look up the ratings on the rating table lookup, do an interpolation to get the flow that will be populated into our data. If we actually jump, we already have one flow rate already defined here, and we can see down at the bottom that data is being reported and derived off of that stage sensor that we showed. So that is flow rate sensors and synthetic sensors. It's really just going to be those two types of sensors. They're kind of in their own subcategory because they're not quite equation based, and there's a little bit more complexity on the calibration and conversion side. But those are the two main types. So if you're doing flow or wanting to get rain or precipitation increment sensors, those are each going to be derived off of a real sensor using either ratings table lookup or a ink up or down sensor type. All right, so it looks like there's no other questions. If you do have any questions, feel free to send them in the questions box. I will do my best to answer those throughout the presentation. All right, so now we're going to get into some equation-based sensors. So I'm actually going to jump to a different Contrail instance. All right, so here is a METAR site down in Florida, and let's just say we want to calculate dew point at this site, right? So just go ahead and ignore the perfectly functional dew point sensor here. We want to recreate this and show you guys how we would create a dew point. For those that are not familiar, dew point is derived using air temperature and relative humidity. And this value is calculated. There's a specific formula that is used to do that calculation. Because we have a specific calculation we need to create a sensor that is an equation-based sensor, right? There's a specific variables and equation that we want to apply to get this derived or synthetically derived sensor. So I'm going to go ahead and click the add button here. So let's go ahead and create a dew point sensor. So under sensor type, I already have a sensor type defined. I will show you how to make that if you don't already have one here in just a second. So we're going to give it a name. We're going to give it, let's call it dew test here. We're going to select equation. It's not a real or synthetic sensor. It's already populated F for Fahrenheit, which is what we're going to use here, especially here in the US. Precision interval. So down under calibration in the conversion type, so instead of direct, this is not going to be a real sensor. There is a specific conversion type, so equation. We're going to want to apply an equation to the data points that we select. Go ahead and click save here, and it's going to drop us into our equation manager. Okay, so if those that are following at home, or if you're watching this recording at a later time, you may or may not have equations defined in here. And it depends on how active your system admins have been in the software. I know we have started in the past to start to have some default equations already defined. If not, don't worry, I'm going to walk through and we're going to create a brand new equation here right now. All right, I'm going to click the add button here. So we're going to give it a name. We're going to call it dew point demo equation. All right, and now we have our formula box here. So formulas are made up of functions. We can do basic information like, let's just say we wanted to take a air temperature and we want to convert it to Kelvin, or let's just say we really just want to apply this particular formula. It's not super complex. We can do basic arithmetic within this formula field here, as well as we have some predefined functions that the software can already do and it already knows about. We have them listed out here. These are just helpers here. Again, go ahead and reference that help documentation down at the bottom here. We can see all the data equation functions that are defined in the software. So things like accumulation or average value, these are pretty popular or common types of equations, and it will give a description as well as the full settings of the equation of how to use it, syntax, how to use it within the equation manager. So I'm going to go ahead and click the weather functions here, and we can see we have a couple of them: heat index, evapotranspiration. But what we're going to want to use is this dew point underscore F, because we're going to want our dew point in Fahrenheit. If we actually go back, we can see our dew point in Fahrenheit. It's temperature F, comma, relative humidity. All right, so let's go ahead and put that in. I strongly suggest giving variable names that are easy to track. The easiest way that I've found is to do underscores. You can call them whatever you want, but it does make it a little bit easier when you're going to either troubleshoot or assign variable names and assign them to the actual real sensors out in the field. It is a little bit easier to keep track of them. The software will automatically, any of these functions that are defined here, any spot that has a variable spot, it will automatically calculate or insert those as variables. All right, so I have my dew point function here. It's going to take the temperature variable and the relative humidity variable. I'm going to go ahead and click save. Now the software recognizes, okay, so I already have that defined. Let's go ahead and give it a new variable name. All right, let's go ahead and click save here. Now every variable does have to be unique between equations. So you can see all the different equations that we have defined here. We scroll down, whatever new variable or equation that you created in the software, it's going to select it by default when you click save. So now we've imported our equation. We've added our special demonstration equation here. It's going to convert temperature to relative humidity. And we can see down below it, this is our variable section of the equation manager. So you can see we have two types of variables defined here, temperature and relative humidity. So I'm going to go ahead and select that. If you already have a dew point equation already defined, like we have here, just go ahead and select those and scroll all the way down to the bottom if you have a lot of equations. And then the next page, we have to assign those variables to sensors that are already defined within Contrail, right? So we have to hook up this temperature variable to the temperature sensor and this relative humidity variable to the relative humidity sensor. So we do that by clicking the add button here. We're going to pull up the site that we're looking at. Air temperature is already selected here because it's first in the list. And we can now see that this temperature value or variable that is going to be inserted into this function or equation will be this air temperature at this Fort Lauderdale Holly location. So we need to do the same thing for this relative humidity. Select relative humidity there. All right, and so now we have assigned the variables that will be inserted into the equation. So we jump back to our dew point test sensor. We could see down at the bottom in the calibration section, we have our equation, right? So we're going to be using the equation, the dew point function, and we have our two sensors that will be used for air temperature and relative humidity. Now, data will not be inserted until new data points come in. Okay, so once a new data point comes in, then it will automatically calculate. So either one of these data points, once it's received, it will trigger that equation and it will insert it into our data section here below. Let's jump back to our METAR section. So for those that maybe don't have a dew point sensor type defined, let's go ahead and make a new one for you. So sensor types, all they are the defaults when you go to create a sensor within the software. These are just the defaults that will be inserted. You can always change them, but it is the more or less a starting point. So when you go to add in the air temperature sensor, you don't have to fill in every single field. So with that, we're going to create a dew point. I'm going to type in, we have several hundred templates. That is a starting point for the starting point. But I selected the dew point template. So I need to create my sensor type. I'm just going to call it dew point demo. That will make it a little bit easier for us to remember to change it. Now, source type, we're going to select equation because we have to use an equation to derive dew point. Again, we're using Fahrenheit here, precision. We're going to keep all that the same and automatically pick the temperature icon, thermometer icon here, as well as the green color. And then down at the bottom, we're going to want to select equation here. So that way, when we go to make a new dew point sensor, it will automatically select that for us. We don't have to remember to change that. I'm going to click save here. So now when we go back to our Holly site, and let's just say we want to add a third dew point sensor for the fun of it. When we select our dew point demo, now it will have all the defaults that we want, right? So equation, all the units, and then the calibration down at the bottom is correctly selected for the conversion. So for those that want to do any sort of additional calculations or things like that, you have to create a sensor type first if you don't already have it. So if you want a dew point sensor, you have to create that sensor type default first before you can begin to create the dew point sensor. All right. So that is dew point. That is using an equation, the dew point equation, to calculate dew point using air temperature and relative humidity. Another common type of sensor-based or equation-based sensor that is used a lot is using some sort of time average. So a lot of decisions are typically derived off of some sort of average, either some sort of lag average or averaging over a particular time period. So let's just say we have a air temperature sensor that is is very responsive, let's just say, and maybe it jumps up and down, and you just want to look at, hey, what is the air temperature over the last hour, right? Maybe it jumps around a little bit too much for your liking, so we want to have an hour average air temperature. So let's go ahead and create that. So we're going to jump back to our system, our METAR system. let's go ahead and create an air temperature hour average. So under template, I would just suggest picking, let's go ahead and pick this average air temperature. This is just a starting point for the sensor type default. You can change everything about it. So let's go ahead and select, let's call it 1 hour average air temperature. That's going to be our sensor type. We're going to have it be an equation, units of precision, that is fine. And let's go ahead and make that actually 1. We'll take 1 decimal point here. We'll leave all of our validation on the right-hand side the same. And then remember at the bottom here, we're going to select equation up at the top. Go ahead and click save. All right, so now we have our 1 hour average air temperature that we're going to look at for when we're deciding to maybe pull somebody in off the field. All right, so let's go ahead and jump back to our Holly site here. Let's go ahead and click add. And just by default, it's because it's the first sensor type in the list, it's the 1 hour average air temperature. I'm going to give it a sensor type name here, and then the sensor ID. Let's go ahead and give it air test. Equation is already selected. We'll keep all of our same validation and calibration down at the bottom. So you can see how quickly this can go once you have those sensor types already defined. You can just quickly add that in. And again, same thing with equations. Once you have kind of your standard equations defined that you're going to leverage a lot, it's as simple as selecting 1 hour average and moving on with your life. But in this case, I do want to show you guys how to add that in. Let's go ahead and say, let's call this air temp 1 hour average. Now, this isn't going to be specific to air temperature. I'm just going to call it that for this demonstration. As you saw in that previous section, you really can use any sort of sensor type for that. But for that, we're going to, for this example, though, we're just going to use it for air temperature. All right, so over on the right-hand side for our list of functions, you can see there is a average value function. So I'm going to go ahead and copy that over. So with that, we're going to give it a variable name. We jump to our documentation here. We can see if it's average value, variable. So this is the variable that we're going to pull that data from, and the number of minutes we want to average over that time period for it. So we're going to call it air temp variable, and we're going to look at it over the last 60 minutes. Right, so it's number of minutes that we want to look back over and average that. Go ahead and click save here. You can now see it's selected on our list here. So we scroll all the way back down to the bottom, click next, and assign the variable to the sensor that we want to look at. So let's go ahead and pull up our Fort Lauderdale Holly site. Air temperature is selected there. And now we have our variables assigned and added in. So now whenever a new value gets inserted for this air temperature sensor, we will go ahead and average all the values over the last 60 minutes. So I'm going to actually jump to this air temperature sensor. If we want to have it insert some data points, we can always revalidate. That more or less pushes all those data points back through our collection device, and it will fill in data for us. I'm going to add a note here so I remember what I did this validation for. So I just clicked add here. It's going to take a couple seconds for it to process and for it to be complete. All right, so now it's complete. Jump to our site here where we can look at all the sensors. We can now see that the 1 hour average air temperature is all that data has been added in. So at this point at 11:30, it looked at all the average data points over the last hour and derived that the average value is 89.16. Okay, so we have a question. Can this equation be applied to previous measurements and how to do it? So this is how I would suggest actually what I just showed. So you're going to want to create a new sensor. So let's just say you want to derive the total water that's, let's just say there's 3 streams that merge into one, and you don't have a sensor there, but you want to add up those 3 sensors to get some sort of total water amount. You can create a new sensor type. Let's just say you want to do it for a particular date range. Create that sensor type, what I just showed. You would probably call it total flow, combined flow. Attach it to one of the sites or create a new site that's just downstream. Just do a simple addition from 3 variables. Define those 3 variables as the flow from the 3 locations upstream. And then if there's a particular date range that you want to apply that to, you do exactly that. So you would go to one of those 3 sensors down at the bottom here. I have to go to a real sensor actually. Go to my air temperature sensor. Under this data section, we're going to click revalidate. And on this revalidation page, you can pick the date and time. And what that's going to do again is it's going to take all of those data points that came in during that time range that you select, and it's more or less going to push, almost re-push it back into Contrail. So it's going to go through our validation parameters, and then any child sensors, any equation-based sensors that are using this air temperature sensor, it will receive those data points. So it's a very quick way if you want to do some sort of calculation within Contrail. It's fairly easy to get that set up. And again, once you have all those equations defined, it becomes a lot easier in the future. You can have a 1-hour average sensor, a 24-hour average sensor. You can have a dew points equation already made. And then when you just want to make a new equation sensor, you just add it in. All right, so we talked about dew point here, and we talked about 1-hour average. Those are both equation-based sensors. But when we look at this air temperature sensor, you can see that data comes in roughly once every hour, right? So this is an hourly based sensor. Maybe transmits a little bit more frequently, maybe if it has something to say, but that's just the time it sends can be completely random or changing. But let's just say we want to have a data point every hour, right? For reporting, for visualization, whether we have a data point or not, we want to have some sort of hourly data point. And so we want the software, whether we get a data point in that hour or not, we want it to trigger a new data point at the top of every hour, and maybe averages the total air temperature over the last 6 hours. So that is where time series equation-based sensors come from. Again, this is walked through very clearly within our documentation, so I suggest taking a look at that. But I will try to cover this pretty quickly here, just so we can show that. Okay, so I'm going to jump to our system. First, we have to create a sensor type default. So let's go ahead and say, let's just say we need to look over the last 6 hours. That's just our average period that we're going to look at. Let's go ahead and select air temperature here, and we're going to call it a 6-hour time series air temperature sensor. Okay, so we're going to select equation here. Convert the units to Fahrenheit here. Actually, we want to use Fahrenheit. All that information will remain the same. We're going to select under the conversion type, instead of equation, we're going to actually select this time series sensor as the conversion type. And we'll see here in just a second. Let's go ahead and click save. We'll see that our new sensor type default is defined here, our 6-hour time series air temperature. We're going to want to actually select this drop down, and under settings, we're going to get a list of kind of secret settings. Go ahead and be careful here. We're going to want to make sure that these 3 options are selected. So time series interval, time series interval mode, and time series offset. We'll see that in just a second why we want to do that. These are already selected here by default because I made a sensor type system with this just before this. But yours may or may not be selected. Just go ahead and verify that that has been selected. All right, so let's go ahead and add in our sensor. So let's go back to our Holly site here. Let's click add. All right, and so we're going to select our 6-hour time series air temperature. Let's give it a name here. Go ahead and call it test. You can see it's set up for equation. And down at the bottom, it has time series as the conversion type. Go ahead and click save here. Again, we're going to pop up a new equations window. I'm going to add a 6-hour equation just very quickly. 6-hour average, sorry. We have 360 minutes that we want to average over. Go ahead and click save. It's already selected, so I'll go ahead and click next. Go ahead and assign our temperature sensor to this variable, temperature. All right, so down, let's go ahead and go back to our new time series sensor. Okay, so we're gonna get this error at the top that it's a time series sensor and we have not set up our settings. So here, this is where we're gonna set up all of the information and settings about the time series sensor, right? So it's an equation sensor. We are gonna apply that 6-hour average equation that you saw using the air temperature, but we're gonna wanna actually create a time series data point, right? We wanna value every hour that's looking over and averaging over the last 6 hours. So we're gonna select 1 hour. We're gonna type 1 hour under the time series interval type. We're going to get an option whether we want it to be the end of the interval that we assign the time series time step to or the beginning of the interval. If we want any sort of offset, so if you have some sort of reason that you want it to start every hour, but we actually want it to start at 1 hour and 1 minute past the hour, right? We can go ahead and put that in. I'm going to leave it at, I'm just going to say 0 seconds. But if you had a particular offset you wanted to use that for whatever reason, that's where you would put that. So if you wanted to create a 24-hour time series average, you would select 24 hours here. If you wanted to have 6 hours, you would put that in. Go ahead and click save here. And now we have our time series sensor created. So this time series will generate an hour report. Whether we get a data point or not from this parent sensor, it will create a new data point every single hour. And the way it makes that data point is it averages over the last 6 hours. So this is a really great way for flow measurements. If there's some sort of hourly flow rate time series that you want it to create, whether you have a data point or not, this is a great tool to have that time series generation every hour. All right, and so with that, I'm going to check on our questions here just to make sure we don't have any questions. Okay, it doesn't look like we have any questions. I'm going to go ahead and allow our attendees to unmute themselves. If you're not able to unmute yourself, feel free to send a question within the question box. In the meantime, thank you everybody for attending the webinar today. If you do have any questions, I will post our contact information here again at the very end of the presentation. And if not, feel free to send an email to contrail.support@onerain.com with anything that you saw today. We will try to make this recording available So if you have a coworker that was unable to attend, you can pass this along to them.